Welcome GCC students. This is Predicting Products 1 with Dr. Kim. In Kim 130 at GCC, you have to predict products and write them in balanced reactions for 3 types of reactions. Those reactions are combustion, single replacement, and acid-base reactions. To recognize these 3 reactions, you need to be familiar with them. Combustion reactions involve fire. What do you need in order to have fire? That is correct. You need to have oxygen gas. So combustion reactions always have oxygen gas on the reactant side. And they always produce CO2 and H2O gases because they are hot. Single replacement reactions can be recognized because you have a single metal by itself. Hopefully you've watched my single replacement reaction videos and are familiar with those. Finally, we have acid-base reactions. Acid-base reactions involve an acid, which is a hydrogen-containing chemical, and a base. In Chem 130, we will use metal hydroxides as our bases. So you're looking for an OH chemical. You have an H and an OH that make, what do you think? HOH? Correct, that's water, H2O. And that's how you recognize an acid-base reaction. So let's pretend you have this on an exam. H2CO3 aqueous plus KOH aqueous with an arrow and no products because you have to write them. First of all, could this be combustion? Do we have oxygen gas? No, we don't. What about single replacement? We have a metal, but it's not by itself, so it's not single replacement either. Do we have a hydrogen chemical? Yes. Do we have a hydroxide chemical? Yes. So, this is an acid-base reaction. As we just mentioned, acid-base reactions have the hydrogen and the hydroxide combine to form HOH, which is water. Water is a solid, liquid, or gas. Correct, liquid. Now we have to predict the other product. What's left over? Well, we have CO3 left over and we have K left over. So those are going to combine together to form our other product. Which do we write first, the K or the CO3? Does it matter? Well, it does. We always write the metals first. So K is first and then CO3. Now, I hope you remember that every time you bring a metal and a non-metal or polyatomic ion group together, you have to check the charges. Let's do that down here like it's scratch paper. Potassium. Let's find it in the table. It is an alkali metal, column 1. What's the charge when they're in a compound for column 1? You are correct if you said +1. What about CO3? Now that contains more than one nonmetal because we have a C and we have O. That is a polyatomic group. Polyatomics are listed in the bottom of the Chem 130 table. We can see that CO3 is called carbonate and it has a -2 charge. We need compounds to add up to 0. Does +1 minus 2 add up to 0? No, it does not. What do we need in order to make this add up to 0? You're correct if you said another potassium. Now we have +2 to go with the -2, which adds up to 0. Therefore, the correct formula for potassium with carbonate is K2CO3. We need the state for K2CO3. As a compound, we need to look at our solubility rules. For solubility rules, we are looking for K or CO3, whichever we come to first. Now, I found K in rule number 1, but I found CO3 over here on the insoluble side. But we go with the rule we come to first, which is rule number 1. So rule number 1 applies, not rule number 6. Rule number 1 says potassium is soluble. That is the rule we go by. So potassium carbonate is soluble. Soluble means aqueous, dissolved in water, and gets an AQ. Now we have written our proper formulas. We have also written our states. So we are ready to do the last thing that we always do when we're writing products, and that is to balance. Balancing is always last. I have two H's and I have one CO3 group. Because CO3 is on both sides, I'm going to balance it as a group, not as C and 3 O's. I will balance CO3s. I also have a K and I have hydroxide. Now here's a little tip for balancing acid-base neutralization reactions. We're going to balance the water as though it was an H and an OH. Okay, that will make our life easier. And of course they have to be equal on both sides. And over here we have two Ks with one CO3 group. All right, let's look. I have one K, here I have two. So what can I put in front of KOH? You are correct if you said a 2. This gives me a second K and OH. Two Ks are now on both sides. It gave me two OHs. Here I just have one. So what can I put in front of water? You are correct if you said a 2. That gives me a second water, which in acid-base reactions only, I balance as H and OH. This gives me two H's, which is good because I have two H's on the left side. And then I have one carbonate group on both sides. This looks balanced. Let's double check. Two hydrogens, one carbonate, two potassiums, two hydroxides, two hydroxides. I believe we have correctly written and balanced this acid-base reaction. Good job.